Hi, Assalamualaikum. My name is Aisyah Imani and I'm from Bandar Bukit, Mahkota. I am here to tell you about MicroBit MoverBot. My supervising teacher is Puan Marziana Binti Mahkota. I myself, as a school librarian, often face fatigue, strain, and inefficiency. The book racks in here are heavy and hard to move manually. The current strollers are very bulky, non-intelligent, and still require much effort. So, there's a need for a smart, compact, accessible solution with minimal human effort. The objective of this project is a MicroBit-controlled robot with Mecanum wheels for full-range movement, built with the MakeCode program, which is simple, programmable, and easy. The user can maneuver the bot using a remote control for safe and easy handling, which means it is capable for moving book racks with minimal effort. For the parts and components, we use 2 microbits from the junior kit, 1 basic game handle for the controller, 4 Mecanum chassis and wheels, 1 motion bit, and 2 microservers. With those parts, we can build a custom-built arm for rack locking, enabling high maneuverability with the lightweight chassis. Here's a technical explanation of our bot. The microbit acts as the central brain of the robot, the master microbit as a transmitter and remote control, and slave microbit as the receiver on motion bit board. The MakeCode platform is used for programming the microbit. We use some additional extensions that are GH-bit and motion bit. The basic game handle functions as the remote control with the master microbit. It sends signals via its buttons and joystick when pressed or moved. These signals are received by the slave microbit. Each button or joystick movement corresponds to specific movements for the robot, such as moving forward, backward, and rotating. The motion bit is equipped with slave microbit serves as the interface between the microbit and the motors, providing the necessary power and control to drive the DC motors for the Mecanum wheel and servo motor for the robotic arm. Here is the coding in MakeCode Microsoft. As you can see, this is the master transmitter for the remote controller. We use some extensions as seen in there, the GH bit. This one is now the slave receiver motion bit. We use the functions because there are so many configurations used for the motion bit. We also use an extension here. We use the motion bit extension. Here is the board layout we use for reference for our motion bit. As you can see, there is an omnidirectional movement example that we use as a reference for the motors. How it functions. After the students read books in our library, they will have to place them on book racks. It's the librarian's job to maneuver the MicroBit MoverBot under the set rack. Only then, we control the MoverBot to set spot, enabling the rack to move with the MoverBot. Let me share the challenges and solutions I managed to find. The first challenge was confusion on Mecanum wheel orientation. The robot didn't move as expected. It moved and rotated incorrectly. The solution was to research Mecanum wheel movement patterns online and tested each motor's direction manually. The second challenge I faced were the limited pins available for RC to assign for all Mecanum movement. The solution I found? We organized again with each RC button functions and selecting most important Mecanum movement to apply. The third challenge, how to control 4 DC motor control to implement Mecanum wheel mechanism. The solution is, find the selection of using motion bit expansion board simplifying motion control projects. The fourth challenge I faced, how can the robot navigate under book racks? Well, I designed a locking arm mechanism to secure the robot with the rack before pushing. The last challenge was to find book racks in prototyping this innovation. Me and my father just DIY a simple and low-cost book rack. That's all from me. Thank you for listening. Bye!